Hey guys, it's Ani here and welcome to my YouTube channel. Today we're going to be doing another electronics explained video. This is my second video in the series, and today we're going to be doing a topic that is one of the most confusing topics, I would say, in electronics, which is how to read resistors. And resistors are these tiny little guys you can see here. There's a lot of different sizes of resistors, but they mostly look like this, sort of like a little bead that has color bands on it. There's many different types of resistors, and each has a different value. So first, let's talk about what resistors do in a circuit. So last time we learned what a circuit is and how it works. So today we're going to learn how a resistor plays into a circuit and how to read resistors. So here you can see I have a big chart of all the resistor color values. So we're going to talk about this later, but first let's look at how a resistor helps in a circuit. So remember last time we talked about a water pump. This was the battery. So the water will exit out of this pump and enter in this pump. So this is the negative side and this is the positive side. So this is our battery, okay? So the water will be moving through a pipe or a wire, and it will be going into a faucet. So there's a faucet right here. So this is our light, right? This is our light. So the water is coming in through to the faucet. So a lot of things are different in real life than this example here. For example, a water tank here has a lot of pressure, right? It has a lot of water in it, so the water is going to be gushing at a really high pressure, high speed. So the problem with that is your faucet can only handle a certain amount of speed, right? You don't want your faucet to explode because there's too much water. So usually what there is a pipe that downgrades how much water is going through. And that's pretty much what a resistor is. So usually when we're dealing with resistors, let's say we want to make a simple flashlight. We're using an LED like this one. An LED will be connected to a battery and a resistor at the same time. So what happens is, when the electricity is going through the circuit, the LED can handle the amount of electricity that's being passed in. Because if the electricity is too much, the LED will burn out because there's too much electricity flowing through it. Can't handle that much electricity. So the resistor here will stop the flow of current and release enough energy so that the LED will light, but it won't explode because there's too much electricity. So here we have a resistor which will restrain the flow like that. So then the flow slows down a little bit, and what's coming out of your faucet is safe to use. And that's pretty much what a resistor does. Just stops the flow of electricity. But the problem is there's a really big range of electricity and a really big range of resistance that we need to use, right? So there's batteries that are just 1.5 volts, like normal AA batteries, and then we have the 9-volt batteries. So that's a huge difference right there, right? A huge jump. There's also in the middle, there's those 3 volts lithium batteries, and there's a big range of batteries here. So what we want to do is we want to use these resistors to control the flow of electricity. So the problem with that is, right, if we have so many different voltages, we need a lot of different resistors so that we can control the electricity to a certain point. And that's why we have tons of different types. So you can see we have these 10K resistors, we have these types of resistors, and there's so many more, right? There's so many more types of resistors. There's 5-band resistors. But today we're going to be talking about these normal 4-banded ones. And we're going to talk about how to read them so you know exactly how many ohms of resistance there is. So let's think about that, right? So last time we learned what ohms are. So ohms is the amount of resistance that is being put on a flow of electricity. So in this case, we're going to try to find out how many ohms this resistor will resist. So there's 4 bands total on this resistor. So to find out the value in ohms of this resistor, we're gonna have to first look at the first 3 bands to find the value in ohms, and the last band will tell us the tolerance. So I'll speak to you about what that means later, but first, let's find the actual ohm value. So the first band on this resistor is brown. So let's write brown. So it's a brown band. The next band is black. Black band. And the third band on the resistor is orange. Orange band. Okay. So now that we have our 3 bands here, we can figure out the ohm value of this resistor. So the first thing that we want to see is the first 2 values. So we see here that the first 2 values are brown and black. So we have to look on them on our chart here. So the brown value we look is the digit 1. So the first 2 values here is brown and black. These 2 values tell us the digit number of the resistor. So the first stripe was brown, so brown is 1. So I write 1. Next, black. Black is 0, so we write 0. So we know that our first digit value is 10, just like that. So brown and black, the stripes together, that makes it 10. And then our third stripe tells us the multiplier. So it tells us how much we have to multiply the first value to get our ohm value. So orange here is the multiplier of 10 to the power of 3. So 10 to the power of 3 is 10 with 3 zeros. So that would be 10 times 10 times 10, which is 1,000. Okay, so we multiply 10 and 1,000, and we would get, see, 10 and 1,000, we would get 10,000, right? So 10,000 is our ohm value. So let's write that over here, right? 10,000 ohms. 10,000 ohms. Now we could write it just like this, or we could simplify it so that it looks much better and say 10K, which also means 10,000, right? So 10K ohms. That's how much this resistor resists. 10,000 ohms of resistance, right? Now we look at the last stripe, okay? The last stripe on the resistor. And the last stripe here is gold. It usually is gold, all right? There's very few silver resistors. They don't really make those anymore, but if you can see that the last stripe there, let's turn the light here. The last stripe is gold. Okay? So using that last stripe, we can tell the tolerance. So the tolerance of a resistor is how much is the give or take value. So 10,000 ohms is a very specific value, right? So using this final band of plus or minus 5%, we can say that about 5% increase or decrease we can expect from this value. So this here is about the value that we can expect from this resistor. So it's a 10K ohm resistor with a 5% tolerance, okay? Awesome. So now that we've figured out what this first resistor is, now let's try to work backwards, okay? So let's try to find the color bands on a resistor depending on a value. So for example, let's say we get a value of 15K ohms with a plus or minus 2% tolerance. So how would we solve this for the color bands on the resistor, right? So to find this, first we look at the chart to find our first digits. Let's find out how to get this resistor value with the colors, right? So we have 15K. So that means we know our first 2 digits are 1 and 5. So let's find that. So the first digit is 1, so we find that in our chart, which is brown, right? So our first band, so let's draw a rough outline of our resistor here. Looks something like this. Okay. 2 leads. Okay, so here's our rough outline. Now let's draw in the colors. So first, our first digit is 1. So we draw in our brown line. Our second digit is 5. So we look down and we see the color is green for the 5 value. So we have to color in the next stripe green, just like that. Then we have to find our multiplicity value. So let's write down this here. So our first 2 digits are 15. Then we have to multiply this by something. So let's say that's x, and we will get 15,000, right? So using simple algebra, we can say that this x value, or the multiplicity value, will equal 15,000 divided by 15. So this means that x equals 1,000, right? So if x equals 1,000, we know that the multiplicity value has to be 10 to the power of 3, because that's 10 with 3 zeros, that's 1,000. So 10 to the power of 3 is our multiplicity value. So we look at the chart and we see that orange is our multiplicity value. So we go down here, write in the orange. Awesome. And now our final value here is the plus or minus 2% tolerance, which means again that we can expect about 2% more or 2% less tolerance from this resistor. So we go ahead and mark that with the red stripe, because here red is the 2% tolerance. So here we've just drawn our resistor depending on what the number is. So one more little confusion that I want to reiterate is how to actually read the resistor from which way to which way. So when you look at a resistor, there's always a small gap in between. Normally there's 3 stripes on one side and there's a small gap, just like this one right here. See, there's a gap, and after that comes the tolerance value. This is the tolerance value, right? The red. So normally the tolerance value is gold. It's the most common one. They don't even make the silver tolerances anymore. So normally it's gold. So you always know that if it's a gold stripe, then you have to start from this side and read. But normally it's gold, but if it is black or brown, if it's brown or red, then there's gonna be a gap in between the first 3 stripes and the tolerance value. So you can always tell from which side you have to read. You always read from where the 3 stripes begin, and then the space comes, and then the tolerance comes. So you always read from here to here, right? So that's how you read a resistor and how you tell how many ohms of resistance that it carries. So you can use this to find out how many ohms of resistance you need in a circuit, and how to use them to control electricity in a circuit.